This is the lesson for 3-2 Part B, or Part 2, and it's properties of exponents, and we're looking at simplifying exponents again. And actually we did this in the first section. However, problems are going to be a little bit tougher, and we're also going to introduce the concept of using a calculator to simplify some of these larger numbers raised to powers. And so let's take a look at the first one. It says 5 minus 2 to the 5th power. Well, first thing I need to do is do the work inside the parentheses. And so that gives me 3, and I'm raising that to the 5th power. And then I'm multiplying by 3 to the negative 8th. Now, before I go ahead and multiply 3 to the 5th, I've got a 3 to the negative 8th. So I'm going to want to simplify this in a little bit. And before I do that, though, I'm going to continue moving on and doing the work underneath the parentheses, or inside those parentheses, and I have 5 plus 2 makes 7. So now, instead of combining, or instead of multiplying these 3's out, I'm going to use the properties that we learned. And the property is, if I'm multiplying with the common base, I'm going to go ahead and add up those exponents. So I got 5 plus negative 8, and then over here, this is a rule from the first section, anything to the 0 power is just 1. So I go ahead and combine this. I get 3 to the negative 3rd plus 1. So I need to understand negative exponents, and that was section 1, and that says that just means that we had more exponents left in the bottom of a fraction, so that represents the reciprocal of positive exponents. And so when I go ahead and take the 3 to the 3rd power, that gives me 1 over 27 plus 1. And so that would make a mixed number of 1 and 1/27th. That would be my answer. So looking at the next problem, same sort of thing. I'm going to go ahead and subtract first, since that's inside the parentheses. So I have 4 to the 3rd power. And then I'm multiplying that by 4 to the 2nd power. Plus, and then I have to combine those two numbers first. That makes 12 to the 2nd power. So I'm using the exponent rules, which say when I'm multiplying, you add up the exponents. 3 and 2 make 5. So notice I have 3 4's here, and 2 4's make 5 4's. And then I need to multiply out those 5 4's. Now this is where I'm going to introduce that calculator option for you. And so some calculators, scientific calculators, have this button right here, this X to the Y button, and that one is the one we're going to end up using to figure out what 4 to the 5th power is. So I'm going to go ahead and type in 4, and once I do that, I'm going to press this XY button. Move this over just a bit. So I'm pressing the XY button, and then in some calculators, instead of the XY button, they'll use this little feature here. So either look for an X to the Y button, or this button here that I call a caret. And once I press that, I'm going to press 5, and that says 4 to the 5th power, and then I press equals, and that gives me my numbers. So that would be 1024. And then I need to add on, and I know what 12 squared is, and that's 144. And so I can just add those two numbers together, and that gives me 1168. So moving on to the next problem, I've got some work underneath inside the inner parentheses first, and so they'll leave those brackets out and do the work inside. I end up with 5 to the 2nd power, and that's all being raised to the 2nd power. So I have to use an exponent rule there. On the bottom of the fraction, I've got 5 to the 3rd power. So 5 to the 2nd, all to the 2nd, I use that exponent rule of multiplication. So I'm multiplying those exponents because it's two groups of 5 squared. It makes 5 to the 4th. Over 5 to the 3rd, and now I'm using the exponent rule, which says when I'm dividing, I have common bases, I subtract the exponents. So that's what I'm going to do here. And when I do that, I end up with 5 to the 1st power. And going back to what we learned in the first section, anything to the 1st power is just that number itself. So 5 is our answer. And looking at our next problem, same sort of thing. We've got an exponent rule of multiplication. 3 groups of 2 squared makes 2 to the 6th power. So we've got 3 groups of 2 squared. So 2 squared, 2 squared, 2 squared makes 2 to the 6th. And then minus, and then I go ahead and subtract these. I got 4 to the 3rd times by 4 to the negative 5th. Now the rule is I cannot combine the 2 to the 6th and the 4 to the 3rd because the bases are not the same. So I'm going to leave that 2 to the 6th there. And minus, now I can combine these because the bases are the same. And so the rule is you add up the exponents, but I had some negative exponents here, so I'm going to go ahead and subtract since they're opposite in sign. So now I have minus, and then 4 to the negative second power. So the rule is I have to multiply out these 2's. So again, I'll show you that calculator function again. So if I press 2, and then I press this x to the y button, it says 2 to what power now? And so it's asking me for that, so I press in 6, press equals, and you see that gives me 64. So 64, and then minus, and then I go ahead and do this work here, and that gives me 1 over 4 squared, which is 1 over 16. So this one's a little tougher because I got to subtract 1/16 from 64. So when you do that, you're going to end up having to borrow. So I'm taking away 1/16. And so when I borrow from the 64, I'm going to change that to a 63, and then borrow, I end up with 16/16. So 63 and 16/16 makes 64. Now I can subtract, so I'm left with 63 and 15/16. That would be my answer. So the next problem, using some exponent rules here, we have 3 to the third all to the second makes 3 to the 6. So 2 groups of 3 to the third makes 3 to the 6. Times by, and then I subtract first, so I've got 3 to the third power. And then down below I got 3 to the fourth power. And then I have to add on and make 6 to the second power. So I continue on, 3 to the sixth, and then the rule is I can subtract. So when I subtract, I'm left with 3 to the negative first plus 6 to the second. So here my rule is I add the exponents up, but when I add opposite signs, that gives me a subtraction of those two numbers. So that makes 3 to the fifth plus 6 to the second. Well, let's use that calculator function again. So 3 to the fifth power equals 243. So we'll write down 243 plus, and then I've got 36. And so when I add those two numbers together, that gives me 279. That would be our answer. Well, let's take a look at this one. It says Ed is 33 to the third meters from home. Al is 9.2 times 10 to the fourth meters from home. How much further is Al from home than Ed? So let's figure out how far Al is. So 9.2 times 10 to the fourth. Now, 10 to the fourth is just, when I'm multiplying by powers of 10, you're doing 10 times 10. So let's actually come up with a little rule here. 10 times 10 would be 100. So notice how if it was 10 squared, that would end up giving me just 10 times 10, which is 100. 10 to the third power is going to be 10 times 10, which is 100, times another 10 gives me 1,000. And so 10 to the fourth is going to be 4 tens. So 10, 10, 10, 10. So I've got 10 times 10 times 10 times 10, and that ends up giving me 10,000. So look at the rule here. Notice how with 2 tens, it gives me 100, and there's 2 zeros in 100. Notice the power that we have. 10 to the second has a 2 for the exponent, and we have 2 zeros. Same thing here. You'll notice that same pattern. 10 to the third is 1,000. 1,000 has 3 zeros. 10 to the fourth is 10,000. 10,000 has 4 zeros. So 10 to the fifth would end up being 100,000. And notice that 100,000 has 5 zeros. So there's a pattern. So when I'm doing 9.2 times, and I know this is 10,000, what that leaves me with is 92,000. So when I multiply a number by a power of 10, it's just 1 times that number, and then just tack on those zeros. Here I had to move the decimal back, so that's why I just have the 3 zeros. So that's Al. That's how far Al is. Now let's figure Ed. He's 3 to the 33 to the third power. Here's where I'd want to use that calculator. So let's type in 33 to the third power. 35,937. So let's write that number in here. 35,937. And now I need to subtract those two numbers. Make sure you borrow when you do that, and you end up with 56,063 meters difference is how much further Al is than Ed. So those are the types of problems you'll end up seeing on tonight's homework. Good luck.